Hello students, welcome to today's lecture. So in this lecture we are going to see about IP addressing in IoT and media access control. So IP addressing, most of the devices we are using today which are connected to a network through internet protocol. So which requires an IP address. In order to connect to the network, we have the address is required. So over the last 2 decades, networks, clouds, mobile and IoT technologies which have been rapidly reduce the number of available IP addresses as each technology adds device to the global net. So we are going to see the IP in detail. So yeah, IP address it has a consisting of a header of source and also having a destination address. So this is called an IP address. So the header which has both the source and destination addresses, which includes the network domain. So and also the internet which generally uses IP version 4 address. So IoT or machine to machine which uses IP version 6. So here the IP address which is a numerical representation that uniquely identifies a specific interface on a network. So IP addresses in IP version 4 are 32 bits long. So it is a 32 bits long which allows the maximum of 2 power 32 unique address. So addresses in IP version 6 which allows 2 power 128. Okay, so there it allows more than 2 power 128. So the total usable addresses pool for both the versions which is reduced by various reserved addresses and other considerations. So IP addresses are binary numbers. So they are typically expressed in the form of decimal or hexadecimal form in IP version 6, decimal form in IP version 4 for making reading and using them for easier to the humans. So IP which is internet protocol and describes a set of stands and requirements for creating and transmitting data packets or datagrams across the networks. So internet protocol is a part of the internet layer of the internet protocol suite. So in the OSI model, IP will be considered as a part of the network layer. So it is traditionally used in conjunction with a higher level protocol which is notably TCP. So it is governed by RFC 791. So the version IP version 4 address consisting of 32 bits. Okay. So the example which is however it is considered as 4 decimal numbers which is separated by dots. So for example 198.136.56.2 for 32 bits. So here the binary representation. So in terms of zeros and ones. So each decimal number is of decimal value of an octet, that is 8 bits. So IP addresses which can be between 0.0.0.02 255.255.255.255. So total 2 power 32 addresses due to 32 bit address type. So 3 separate fields with a decimal number which is each for the set of 8 bits which are easier to use. So the example we are going to see about this IP version 4. So with the postal network addressing method. So consider an address which is a postal address. You can mention your name, your street name and your city and then country. So in these examples the 3 fields which are separated by comma. So the 3 fields which are separated by comma and a new line each. So a mail routes to the destination using the address. So first the mail routes to the country, that is India, and then to the city which is mentioned by you, and then to the street and the final destination. Okay. So similar there are the actions when a packets route to a destination IP address from a source IP address. So each device or node which communicates on the internet must have an IP address. So the number of nodes or the devices can be large. Okay. So each sensor or a device is assigned the addresses used internally. So the framework which communicates with the internet with one IP address externally to the applications. One solution for a large number of nodes is dividing the network into internet address and subnet address. So for example, we are giving something named in the street name and also city name. and the country name, so which is globally visible address. So internally the mail is directed to which individual at that particular location, which is decided by an internal distribution network that is invisible to the outside world. So alternatively, the particular city and country which may be globally visible address, but internally the mail is directed to which individual at that particular location and particular street name. So is decided by an internal distribution network which is invisible to the outside world. So internet address is visible to outside world, means it is visible to the routers on the internet. So and then a subnet address is for the use within the group internally, and it is invisible to the outside world. So we are going to see about the subnet. So subnet, which is it is a network consisting of number of hosts or nodes or devices or machine. So here the internet address which is visible to the outside world means it is visible to the routers on the internet. So subnet address is for use within the group and also internally, and also it is invisible to the outside world. So it is a group of a number of hosts or nodes or device or machine. So a subnet mask and a network which has 32-bit IP address after ANDing operation. So here the ANDing operation, okay, takes place. So here my A dot B. So for example, A is the input and B is the output, Y is equal to A dot B. So which gives an subnet address. So logical AND operation with complement of subnet mask with the IP address which gives the host identifier on the subnet. So the IP address 198.136.56.2 is visible to the internet, but the number of servers such as web servers, mail servers and file transfer protocol servers which are invisible. So internal process is invisible, and these have the same IP address globally and separate addresses internally. So it is having two types of addresses. One is global address and another one is the internal address on a subnet of servers or nodes or device. So here is an IP address which serves the purpose of uniquely identifying an individual network interface of a host. The internet interface locates on the network using that address. So the address which enables the routing of IP packets between the host and IP addresses which are present in the field of the packets header for routing. So header indicates both source and the destination of the packet. So this is what about IP addressing. So here the IP address is designed to work over a dynamic network. Okay, so this means that IP must work without a central directory or monitor, and that it cannot rely upon specific links or nodes which are existing. So it is a connectionless protocol, that is datagram oriented. So each packet must contain the source IP address and also the destination IP address and other data in the header to be successfully delivered. So combined these factors which makes an IP a best effort delivery protocol and reliable. So error correction is handled by upper level protocols, and these protocols includes TCP, which is a connection oriented protocol, and UDP, which is a connectionless protocol. So most traffic is on the TCP IP protocol. So next we are going to see about the static IP address. So static IP address which is one assigned by the internet service provider. So ISP, internet service provider, will assign the static IP address. So the server or the service which service provider may be provide an individual or just one address. Okay, so the service provider which may provide an individual address. So when a company has a number of hosts, a service provider may provide a class C network. So based on the group of IP address. So it is having a 2 power 8 minus 2. So next one is the dynamic IP address. So the dynamic IP address which it is once a device which is connected to the internet, it needs to be allotted an individual IP address. Okay. So when the device which connects to a router, the router and the device use the dynamic host to control protocol which assigns an IP address at an instant to the device. So this is called dynamic IP address, that is runtime address. We are giving assigning a IP address at the particular instant to the device. So when a device disconnects or switches off, or the router boots again, then the dynamic IP address is lost. So because it is a instant address, so and a new allocation takes place when the device reconnects. So this is about IP address, dynamic IP address. So next one is that DNS, domain and network service. Sorry, next one is the DNS, that is domain network provider. Sorry, next we are going to see about DNS, which is a domain naming system. So it is considering an IP address that is 198.136.56.2. So it is difficult to remember this data. Okay, so the domain name for the particular address is the author name. So for example, if you are giving any name, okay, so you have to be registered in a particular domain, whether it is .org or .com for commercial users, or .in for a specific country, or .net. So for example, the network domain. So based on that, domain naming systems are allotted. So access to the server, web server hosted at a domain is made using the website name. So for example, www. particular author name or a .org, that is a organization. So access to a web server is hosted at the domain. So access to mail server is hosted at the domain using the mail server name. So that is by using http mail.authorname.org. So another example of domain name is education.com. So here the education.com, which is using the complete another domain. So .com, .org, .in, .us are called as top level domain. So it can be further subdivided into .co.in or .gov.in or go.uk. So for example, it is an india.gov.in, for United Kingdom.uk. Okay. So here this is the top level domain. So in the domain naming system is an application which provides an IP address for a corresponding service from the named domain service. So next we are going to see about a DHCP. So when a sensor or actuator or IoT device or node which is connected needs to connect to the internet, a server called DHCP server, so that dynamic host configuration protocol, which provides a dynamic IP address, subnet mask, and ARP and RARP caches. So the server has its own IP address to provide connectivity to the internet. So dynamic host configuration protocol is dynamically provides a dynamically new IP address and set subnet mask for the connected node, so that it can be used as the subnet server and the subnet router at the communication framework. So IP addresses are configured. So here the IP addresses are configured. An administrator or user does this process. The DHCP enables the processing of configuring IP address automatically at startup. So a node which has a software component for sending request to the DHCP server and receiving response. So the components which is called a DHCP client, and then a client protocol which communicates with the server. So we are going to see the steps for the dynamically configuring the IP address. So this is the steps which covers dynamically configuring IP address using DHCP and for other networks. So it is a client, DHCP client, which broadcasts a discovery request, so known as DHCP discover. So with this one, the new request has been discovered. So here the DHCP server, which is listens to the DHCP discover and finds the configuration which can be offered to the client. So here the client sends a request, and that called a discover request, and server will finds that listens to that particular request and finds the configuration, what type of configuration, so for which the server can be delivered to the client. Okay, so the server sends the configuration parameters, including the IP address which is not presently in use at the subnet. So the configuration parameters are in DHCP offer for the offered configuration. So the selected DHCP server creates and manages bindings. Okay, so the DHCP server also sets a time interval during which the IP address will be valid for a DHCP client node, and also the DHCP server confirms the binding through a message. So it sends DHCP pack after creating the binding. So when the node in the DHCP client computer leaves the subnet, it sends the message as DHCP release. So discover means sending the request. So DHCP release means which leaves the subnet. So if the client does not send a DHCP release means with a specific time interval, then the server frees the created binding. So it allows for the particular time interval. So if it is the request is not ensured means, so the server will automatically freeze the created binding. The server and client also use authentication protocols before considering a DHCP discover from a client and before accepting a DHCP offer from the client. Okay. So the DHCP protocol guarantees that any assigned network address at a given instant is the one which is either one which is DHCP client or none. So this is all about steps in DHCP protocol. So next we are going to see about the IP version 6 address. So here the devices are nodes for IoT which needs a large number of address. So IP version 6 uses 128-bit address. The hexadecimal digits, that is a 4-bit. One hexadecimal digit is 4 bits, 4 of binary to hexadecimal to 0000 to 1111. So therefore 128-bit address has 32 hexadecimal digits. So 8 sets of 4 hexadecimals digits are separated by a colon or a dot in an IP version 6 address. For example, a 16 hexadecimal digits, that is this is an example, so which is separated by the colon. Okay. So internet assigned numbers authority, so IANA, which manages the allocation process for IP version 6 address, and 64 bits in the last when all zeros which can be omitted. So the devices in the mesh network, so use 6LoWPAN protocol, low power personal area network, at the adaptation layer, and IP version 6 when communication framework communicates on the internet using IP version 6. So the last 4 bits that are interface identifiers, the interface which may have a distinct node. So IP version 6 address are classified into 3 classes. So each class differs in primary addressing and routing methods. So an interface which may be at a distinct node, unicast address, that is for a single network interface, and then 48-bit or more in unicast specify routing prefix. So 16-bit are less specify a subnet ID, 64-bit are interface identifiers. So anycast and multicast addressing. So anycast address means a address of a group of nodes or interface. So a packet can send to an anycast address which is delivered to just one of the member interface. So one may be the nearest host, that is nearest is measured according to the routing protocol's definition of distance. So based upon the network protocol's definition with respect to distance, so the nearest is measured. So multicast address means an address which is used by multiple hosts. Okay, so which acquires the multicast destination by participating in the multicast distribution protocol among the network routers. So a packet with multicast address delivers to all the interfaces that have joined to the corresponding multicast group. So this is all about addressing type, IP addressing. So next we are going to see about media access control. So each network which connected node has an MAC address. So media access control. So a device node which receives tags using its MAC address. So the node which receives the data using its corresponding MAC address. So media means a physical media, fiber or wire using which a device or node access to the internet. So the node which can be used the same physical network and IP address. So node means an IoT device or a sensor or actuator or control or computer, the data link layer of which communicates to the internet. So MAC address is of 48 bits. So each network card or Ethernet protocol using a communicating node as an unique MAC address for the source and the destination node address. So Ethernet frame which communicates before the data stack source node and also a MAC address and destination node MAC address. So the MAC address of each node is specified in the firmware of the network card or a chip or a core. Here the usage of ARP which enables each node to be addressed by the MAC address. So the node which receives the network data from a router having an IP address. So here the ARP and RARP which can be used for address translation. So usage of RARP enables each node for sending on the network the data to a router which is having an IP address. So the ARP which refers to address resolution protocol and then a reverse address resolution protocol. So address resolution protocol uses a lookup table. The network 32-bit address provides MAC address of the individual node using the table. So reverse address resolution protocol also uses that lookup table. The table stores the IP address in one column and MAC address in the another column in each row. So the number of rows is equal to the number of nodes connected to the network or internet. So the individual node which MAC address provides the network having a 32-bit address for the internet. So it is having a 32-bit address for the internet using the table. So the lookup table is a table in which value in a column of row is used as a key to look for the another value or a set of parameters from the another columns of the row. So here the ARP cache servers just a building up of the table for the address translation of the data stack which is received at the internet layer to the node MAC address. Whenever the first time the network sends the receiver IP and MAC addresses or a node sends the sender MAC and IP addresses. So they save a cache called ARP cache. So the cached address build a lookup table for the next communication between the node and the network. The process enables the node to transmit and receive the IP packets at the new IP address from the internet by the address resolution. So alternatively, an address can be stored locally in a memory card or flash memory of a board or a microcontroller chip. So software when the microcontroller starts reads this address. So the board or chip which connects to the Ethernet LAN uses the saved MAC address. So the chip connects to the internet using this address and RARP. So the chip also receives IP data using ARP. So far we have discussed the IP address version 4 which consists of 32 bits and IP version 6 which consisting of 128 bits. So and also the subnet which is a network of devices or nodes or machines or computers which connect using a common IP address. So and then DNS, the domain naming system to translate top level domain and the domain name into IP address and vice versa. So IP address which can be a static or dynamic one. So dynamic which configures and provides an IP address for the internet and at a certain specific interval.